Hey everybody, this is Saka, and I'm going to review one of the problems from your, I think your homework that doesn't count for points. Either way, it's a good problem to go over. So this is an honors one. Here we have a photon, we have joules of energy, and we want to know the wavelength. Now, before we start, let's think about what equations we have to work with, and we can come up with a strategy to solve if you don't know that already. So because of energy, we definitely know that Planck's equation is going to be in the mix. So E equals h times nu. But notice in this equation you see no lambda, no wavelength. So that means that we're also going to have to use the wave equation, which is C equals lambda times nu. So we can see here that our nu is going to be our bridge between Planck's equation and the wave equation. You could actually substitute and combine and just incorporate this into the energy equation, but I'll break it up into two parts to make it a little bit easier for you to follow along. Okay, joules is our unit of energy. If it had been kilojoules or something like that, we would have to convert, but because it isn't, there's no metric prefix in front of joules, we're good to go as far as solving for this. Remember, we're going to use E equals H of V first, so we'll use this one first, and then we'll use the C equals lambda nu second. So let's go ahead and let's go ahead and use number one. So energy we know is 7.77 times 10 to the minus 19th joules. And we know H is a constant, that's 6.626 times 10 to the negative 34th joules times seconds. So we're going to solve for nu here. So doing some algebra, E over H equals nu. It's supposed to be an H. And we go ahead and put that in, so 7.77 times 10 to the minus 19th joules divided by 6.626 times 10 to the negative 34th joule seconds. Joules cancels, leaving us with 1 over seconds, which is exactly what nu is. And so let me break out my calculator, see what I get for that. So let's see, 7.77 plus 10 to the negative 19th divided by 6.626 times, oops, wrong thing here, times 10 to the negative 34th. And when I do that, I get 1.17 times 10 to the 15th 1 over seconds. So I've used equation 1, now I'm going to go ahead and use equation 2. So now C, so this is equation 2, so C equals a constant, which is 3.00 times 10 to the 8th meters over seconds. And nu we just got from from equation 1. So if we do some fancy algebra one more time, we get C over nu equals, so that's a nu, equals lambda. And so we have to substitute and solve. So 3.00 times 10 to the 8th meters per second over 1.17 times 10 to the 15th 1 over seconds. So 1 over seconds cancels, leaving us with meters, which is good. So I know I put numbers in the right spot. And when we divide this, we get, give me a second here, we get, I get 2.56 times 10 to the negative 7th meters. Okay? And that's how you do that. And maybe I'll do another one tonight. If not, I'll definitely do one tomorrow. Enjoy for now, and hopefully this makes more sense.